Hi, this is the comprehensive EPS question, and it's the third video where we're putting together the ranking of the potentially dilutive securities. Very exciting stuff. So you should already have basic EPS worksheet done and the basic weighted average shares worksheet done if you're watching this video. So I am going to just walk through this step by step, and most of it's going to be done without formulas everywhere. Someplace we'll just put some numbers in. Now, I have already filled out the assumptions here just to speed this video up. For you doing your case, you'll have to put some assumption up here for the conversion ratio. I'm going to stick with 50. So what we have to accomplish here is figuring out the per share effect, which is going to enable us to do two things. First is we're going to throw out any per share effect that is larger than basic EPS. We will not include it at all in diluted EPS calculation. But the second thing we're going to do is rank from most to least dilutive, because that's how we're going to find, you'll see in the next video, the reported diluted EPS. So all we have to accomplish here is find out the per share effect for all the potentially dilutive securities and exclude all these securities who are anti-dilutive relative to basic earnings per share. So up in panel 1, this is just all the information you're going to use. So what I'm going to do now is just let's see if that'll work. Cumulative convertible, bond A, bond B, and then for me, this is easier than typing the whole thing, so I'm just pointing to the names. So we have the security names in here and warrant fee. So what we have to do is calculate a numerator effect. What would income have been if the convertible preferred security would have been converted on day 1 of the year or on the date issued? So this cumulative preferred was outstanding at the beginning of the year, so the time weighting factor is 12 over 12, which is 1, obvi. So we don't have to really worry about that. I'll just put it in for completeness. So it equals the time weighting times, this is cumulative preferred, so the amount we subtracted from net income for basic was the amount of the current year's dividend. So it's times 1,000,000 shares times the 5% dividend rate times the par value of 100. And it's not liking something, equal F. This should be a 5. I hit the wrong one. Okay, and I am going to use my format painter just to make life a little easier. Now, for the denominator, we need to figure out how many shares would have been issued if it would have been converted. Remember, this is just an assumption for an analysis. So the time factor is 1. Then we want the conversion ratio. And then you're going to get 2 common shares for each preferred stock. And there are 1,000,000 preferred shares. So they would have avoided 5 million of dividend, but they also would have had to issue 2 million shares. So if you're a current owner, you like that you're adding back the dividend, but you don't like that they're issuing shares. So that's why we have to figure out which wins out. Okay, that's 250. Now I moved my basic EPS here from the basic EPS sheet. I just pointed to it. So 250 is greater than 210. So this is anti-dilutive, which is nice because we won't have to put it in the next sheet. So it makes life a little easier. All right, so for bond A, we're going to do a very similar thing. Equals the time weighting times the face value times the interest rate times 1 minus. So for bonds, for preferred dividends, you don't have a tax effect. For bonds, you do. So you have to take out the tax benefit. So it's interest avoided net of tax benefit. And I have the tax rate down here, which is 0.4. So if these had been converted net of tax, our income would have been $1,080,000 higher. All right, now moving ahead. So the time weighting is 1, the conversion ratio is 50. Here's the kind of tricky part. The number of bonds is the face value divided by 1,000 because bonds trade in $1,000 increments. Okay. For some reason, I'm not liking that, but let's see what happens. And once again, the per share effect. Okay. 0.72. We don't know the ranking because we haven't done the other ones yet. And I think this one's right under it. So let's see. Oh, no, that did not work. Okay, so I'll try it over. Oh, I know what happened. This should be B20. So if the right thing to have done would have been to put a $sign in there so it didn't move. So this is 80 cents. So that's 7/12 because it was issued during June. So you have June, July, August, September, October, November, December. That's 7/12 left in the year. Times the face value times the interest rate times 1 minus the tax rate. That's the 560. And then 7/12 times the conversion ratio times 40 million divided by 1,000 ends up being the 80. Okay. Now looking at the warrants, we don't use the per share effect to test for whether or not warrants are dilutive because they have no effect on the numerator. They have no effect. That is, they have no effect on net income. So what you have to do is compare the strike price to the average price per year. So warrant A, warrant A has a strike price of 4 and a share price of 10. So if you could buy at 4 or 10, what would you buy at? You'd buy at 4. That means you could have rationally, would have been reasonable for the holder of this warrant to exercise it. In the second case, warrant B, the strike price on the option is 12, but the average price during the year was 10. So you would just as soon buy in the market and not exercise your option. So warrant B is anti-dilutive. The $12 market is greater than a $10 market, excuse me. $10 market price is greater than, less than the $12 strike price. Okay. So you're not even going to mess with this one. All right. Now warrant B is dilutive. So we know the numerator effect of, just because I told you there's no income effect, that's 0. So this per share effect, it's going to end up being 0. What we have to figure out is how many shares are issued. What the treasury stock method says is take the cash from exercise, which is $4 a share, on the 5 million shares. So that's 5 million times $4. How many shares could you buy back at 10 million and net those out? So, but the way you get there is you say, take the 5 million shares and you're going to take it times the ratio, which will tell you how many you buy back. So it's the market price 10 minus the strike price. So the difference between that is $6, right? So you're getting $4 back a share, but the market price is 10. And then if you divide that by the market price, let me just bracket, I don't have to bracket this off, but just to let you know that that ratio, and it doesn't like my syntax. Okay, so maybe I won't. 3 million, okay? So you were able to buy 40% of the shares back, right? So, and net you issued 60%. So you took the $4 a share, which is 4 out of the 10 bucks is 40%. You're able to buy 40% back, and then 60% times 5 million is 3 million. You ended up net issuing 3 million. Okay. So this warrant A, you issue 5 million, and then you take the 2 million shares, and you buy the $2 million, and you're able to buy 2 million shares back. Okay. The $20 million, buy 2 million shares back. So that's the treasury stock method. Now, the ranking is 1 here, 2 here, and 3 there. So we're going to take this information from these ones that are ranked. The other ones we're going to forget about. And in the next video, we'll go to the final calculation of diluted EPS.